So let's review some clinical MCQs with respect to what we discussed in class today. So let me highlight my pen so I could be able to touch the answers. Question 1 says, apart from carbohydrate metabolism, insulin can also stimulate the conversion of what to what? The answer to this is option A. So that will be from acetyl-CoA to fatty acid. So that's the answer to that one. Question 2 says, the conversion of acetyl-CoA to malonyl-CoA, it's inhibited by palmitoyl-CoA. I told you guys that the enzyme is in a dimer and it's phosphorylated. Insulin will take out the phosphate group, while citrate will turn them from dimers to polymers. But the reverse now, it's inhibited by glucagon, which phosphorylates them again. That's after long chain fatty acid like palmitoyl-CoA must have converted them from polymers back to dimer. So the answer to this is going to be option D. Then question 3 says, the conversion of creatine to creatine phosphate is catalyzed by the enzyme creatine kinase. That's option C. So A, D, C for question 1, 2, 3. Let's go to the next set of questions now. Question 4, 5, and 6. Let's do 4, 5 first. Question 4 says, an enzyme catalyzed reaction that can replenish the supply of intermediates of TCA cycle is called an aplerotic reaction. So that's the answer, option C. Question 5 says, a plot of 1 over V naught versus 1 over S. This is Weber-Burk plot, and it's usually talking about double reciprocal plot. So that's option C for question 5. Then let's go to question 6 and 7 now. Question 6 and 7. A metabolite that binds to an allosteric site of an enzyme that alters its kinetic kinetic characteristics is called a modulator. So that's the answer to this. Question 7 now says, the steps in an enzyme catalyzed reaction with the greatest activation energy. This is what they're talking about. This point where you have the enzyme, this area here where you have the slope being formed, it's called the rate constant step, called the rate limiting step, it's called the rate determining step. So all of the above would be the correct answer here. Let's look at question 8 and question 9 now. For question 8 and 9, desaturases are enzymes that catalyze the introduction of double bonds into hydrocarbon portions of fatty acid. That will be option A. Question 9 says, enzymes that catalyze condensation, not enzyme classes, but enzymes that catalyze condensation reactions using ATP or another nucleoside triphosphate as energy sources are known as synthetases. Ligases would have been correct if it says enzyme classes. So that's it for this. Question 10 and question 11 now. It says inert molecules that are transformed by enzymes at the active site into reactive substances that inversely inactivate the enzymes are called. I use an example. I said the enzyme is a rich lady that picks a poor boy that she loves and makes the boy rich. She activates the boy and the boy ends up inhibiting her. So she committed suicide without knowing. So that's called suicide inhibitors. Question 11 says acetate required for the synthesis of fatty acids in the cytosol is shuttled out of the mitochondria as citrate. Don't forget, in a high carbohydrate meal is eaten, it becomes pyruvate, and pyruvate enters the mitochondria and undergoes conversion to acetyl-CoA, which becomes citrate by condensing with OAA and undergoes the TCA cycle. But at the point, the TCA cycle will shut down and citrate will accumulate and leave the mitochondria into the cytosol and be converted by citrate lyase into acetyl-CoA and OAA, and then it can then use acetyl-CoA to make fatty acids. Question 12 and question 13 now. An NADPH-dependent enzyme that catalyzes the conversion of malates to pyruvates in cytosol is called maleic enzyme. So that's the enzyme there. Question 13 says, the rate limiting step in the biosynthesis of fatty acid is catalyzed by acetyl-CoA carboxylase. As we said, this enzyme is an ABC enzyme. Let me write that very well. It's an ABC enzyme, which means it needs ATP, it needs biotin, and it needs CO2. So it's an ABC enzyme. Question 14 now and 15. Fatty acid elongation is most active in the endoplasmic reticulum. So that's where it's most active. And what we use to elongate it is called malonyl-CoA. So malonyl-CoA is to elongate the fatty acid in the ER. Some elongation do occur in the mitochondria, but both elongation and desaturation they occur in the ER. And remember, we can't desaturate fatty acid beyond carbon 9. That's why any fatty acid that has a double bond beyond carbon 9 is an essential fatty acid. Question 15 says fatty acid biostasis involves 4 sequential and recurring steps. Remember, I call them every course rep will become a doctor. So we'll call them CRDR. C stands for condensation, R is reduction, D is dehydration, and R is reduction. So that's the answer here. And option D is the correct answer here. Now to the last question, question 16. Let me do that again. Essential fatty acids are linoleic and linoleic, so that's option C. So that's the correct answer for this now. So let's see what you guys scored. This is Shola zone. Shola, you tried, but you had about 10 questions correctly. I'll mark the rest soon.